Gentlemen, welcome. We're here today. We're looking at my friend Log Trucker's 3cx3000a7. So I've covered this in about every 3000 video I've ever shot, and it's really frustrating to me to people when they won't even look at a YouTube video to try and understand what's wrong with their amp. My friend Don has had sweep tubes and 3500Zs and 4-1000s and 250Bs and 1500s and all that stuff, but he's never had himself a 3000, and he's always wanted to have a 3000. The difference between most of those amplifiers and this amplifier is this has vacuum variables on it. Okay? Well, my friend Don, let's turn this on. My friend Don is sitting over on, in the great state of Washington trying to figure out how to tune this thing, and he can't get it to put out any power. And I said, Don, bring me that 3000, bring it over here, and I'm going to very quickly, with the power of the proper network analyzer, something that updates real time, not like your Rig Expert AA35 Zoom that you guys are so addicted to, which are garbage, by the way. Look, they're not that bad, but they are that bad. Because to achieve what I'm going to do here for you guys on video right now takes an amazing amount of effort with those intent analyzers, because you constantly have to hit refresh. Where this thing, I can just on the fly, live, real time, see what we're looking at. So the green indicator is channel 20, roughly. It's shown right here, 272227, and then 26, somehow the little red marker got moved. 269161, so it's close enough to 26915. We're at 10 megahertz wide, and that's what we're looking at, and the center is 27, channel 20. He's sitting on his side of the street, and he's got his vacuum tuner all the way backed out trying to figure out how to tune this, right? And so he's got his driver hooked up. That's a whole nother thing we're going to get into in a minute. He's got his driver hooked up, and he's putting 300-400 watts into the amplifier. He's like, man, this thing's getting really hot. It's not putting out any power. There's something wrong. And I'm like, no, it's just out of tune. So once you see this, so like here, we'll take and we'll change the span on this, and we'll make it so it's 100 megahertz wide. Now what I'm going to do is I'm going to reach up here, and I'm just going to start tuning this knob out. And watch what happens. This is frequency and width, like 100 megahertz wide, and the dip, this is an SWR. The bottom is 0, the top is infinite. We'll back these all the way out. There's no turn counters. This is a Bojangles 3000, by the way. There's no turn counters. There's no indicators. I mean, I added these pieces of tape just so I could have a visual aid to help teach him how to tune his amp. So now let's go down in here and let's start looking at this thing. Ready? So first we're going to take the tune knob, we're going to adjust it. That's our capacitor that we're adjusting to get ourselves a resonant dip. And we're matching to the antenna. Now the part that I can't tell you about, because I didn't show you about it yet, is that we have the tube set up with an emulated resisted load. If you look on any data sheet for any tube in the history of amplifiers, it will show you the amount of resistance. See how we're creating a dip that's coming in here into resonance? Look at this. So we keep adjusting. Oh, now we're getting pretty close. Let's go ahead and we'll grab this and bring it on down. Bring it on down. We'll back this out a little bit.
Boom.
Boom. 1.5. It's so easy if you don't know how to visualize this to get yourself to where you can't even tune the amplifier and then you get frustrated, right? That's how you were feeling, Don. You were getting upset with it, right? Because you couldn't
yeah.
figure out how to get it to be tuned. When he got the amplifier, there was no markers, no indicators, no nothing. So now that's somewhat resonant. That means all the power that the tube is producing, we have a resistor hooked up to the tube over here on this side of the amp going back to case ground. So without any high voltage being attached to anything, we can simulate the tube in operation. So let's go ahead, we'll back this all the way out again and we'll start all the way over again, right? We'll get it way out of whack. So now, we'll start with the load knob, or pardon me, the tune knob. Load is the antenna. So now we'll see, we've got ourselves a pretty resonant dip. So we'll start putting some input into this thing. There it shows up. Now we're a little high. So we're going to back our load out real slow. You're going to see the dip's going to start to come down. No, we'll add more to it. And our dip comes down. And we'll start backing this out and it moves the frequency over. So now let's change the span on the meter so we can see with more clarity. So now we'll go to 10 megahertz wide. Does that make sense now? And we'll dial this in. Oh, look at that. So the lower that we can get this dip, remember, the little green indicator is up here on what they call M2. We see that? It's a 1.3 SWR. So let me just kind of massage this around a little bit, very slowly. There's a 1.3. The problem with vacuum tuners is it's all in or all out. All right. So we can clean up this double hump. We're trying to get rid of this hump right here. But once you can visualize this, like lay your eyes upon it and see it, there we go. That's stable.
Boom.
So now the trick, gentlemen, is pretty simple. We want this to be as low as we can. Now the problem that most people have, it's the same thing that we have go on when people go to tune their antennas. I get this same statement at least once every week. Man, BBI, I hooked up my antenna analyzer. I got my AA35 zoom or my MFJ 259B, and I'm a goddamn rocket scientist, and I've got that SWR on my antenna at 1.0. It's perfect. My X and my Y and 50 ohms, and my penis is large, and man, I'm the man. And then I turn on my 8-pill, and my SWR jumps up to a 1.7. What's wrong with my amplifier? Nothing. All this fiddling around with all the knobs is great, but we have to have a reference point. This is just to get us safe. This is just to get us within the ballpark.
The safe zone.
Once we're done with this, we take this analyzer and we put it away. And we're done using it as a reference. This puts out 1/4 of a watt. This amplifier, the tube that's in here, if the plate voltage is at the appropriate amount, we can get 10,000 average and like 18, 19,000 peak. So what do you think the electrical resistance difference between 1/4 of a watt and let's say 18,000 watts is? It's huge. And we all know as we go up in voltage, our resistance goes down. Hence the reason why we have AC conductor lines that are at 600 and 500 kVA that are stretched all over this country, because at that high voltage, the resistance is very low. Well, that means this information is no longer valid, but we've got the circuit tuned close enough that we're going to be within half a turn this direction, and a half a turn this direction, and a half a turn this direction, and a half a turn this direction on the tuners. So we have to retune. Hence where the term comes from, we always tune to your highest output power on your antenna. Well, it's the same thing with your amplifier. We always tune for the highest peak numbers that we can get out of the amplifier, and then we do not retune. So the difference between channel 20, zoom in here, channel 20, which is the green marker in the middle of the thing, 1.08 and 26915. You guys ready for this? Check this out. On this particular amp, the way it's set up, the difference between that a quarter of a turn. And you'd never know that unless you could visualize this. Now, did you have this moment today where you felt like somebody took a light bulb and put it above your head and went bling and it turned on, right?
Yeah.
As soon as you could see how this works, now you understand how the vacuum tuners are set up.
Between night and day.
Right.
When you're in the dark and, hey,
now
I got daylight now, I know what's going on.
We spent 3 hours on the phone with me trying to explain this to you over the phone. And I could tell just by listening to your voice, you're like, well, I don't know there, Luke. I think you're trying to blow sunshine up my ass and only poop comes out of that thing, you know what I mean? And I said, just bring it over here, we'll take a look at it.
Yeah.
So now right now everybody's asking, well, what's the deal with this tuner? Well, I was explaining to him how to tune his input. This is what controls the standing wave ratio between his driver and the tube, is this one knob. It's a pi circuit, not a pi L. This is a pi L. Capacitor, inductor, capacitor. This is a capacitor and an inductor and then the tube with a blocking capacitor. We're going to show you that here in a minute. This, we have to make an adjustment. Would you agree?
Yeah.
Now that you've seen it,
Exactly.
you understand that this might have worked 40 years ago when we were all running around with sweep tube amplifiers as drivers, right?
Yeah, oh yeah.
Because a sweep tube amplifier, you can match the sweep tube amplifier to the input of the amp, right?
Right.
That doesn't work so hot today with solid state boxes, does it?
No.
No, it has to have a flat input SWR. So let's go ahead, we'll stop this. And let's set up so we can show you the input. Okay, let's cover input tune. So we're going to be adjusting this knob, which turns this air tuner, okay? We have the relay closed, and we have the antenna analyzer hooked up to the input. So the RF comes in, goes through this piece of wire instead of a piece of coax, which is not technically correct, but it works. The reason we'd want to use coax is because when it's a wire, this now becomes part of the tuning network, where if it's a piece of balanced 50 ohm coax, when we put the lid on, it doesn't affect that wire. But comes in, hits the tuner, goes to the coil, goes directly through a piece of RG400 and attaches to the bottom of the tube socket right here and goes through these blockers. Without having a second capacitor in line, this is what the input tune looks like. Remember, we're shooting for either channel 20 or 26915. So the best input SWR this amplifier can ever have, naturally without messing with the coil or messing with adding a second tuner, is a 6. It's an SWR 6. So for every 10 watts you put in, you're getting 6 back to your piece of equipment. So if you're putting 1,000 watts in, that means you're getting 600 watts back to your driver piece of equipment, which means, holy fuck, you just blew up your driver. Hence the reason why a couple things we had to fix today were blown up. Okay, now back in the day when we ran sweep tube amplifiers as drivers, you could tune your sweep tube to the input of like one of these things. So now what's the lowest SWR that we can find anywhere? We'll slowly turn our knob around. Oh, look at this magic that's happening. No, no, no. Let's look at what we're doing with the knob. Watch what's happening. Here's where we're naturally-ish resonant, kind of, sort of. Somewhere right in there. Oh, oh, look at what's happening. Magic is happening. So now while Don's been here, I was explaining to him. Once again, we'll look back over here to our reference. The width of this gap is controlled by one piece of a circuitry, and it's on the top and the bottom of the tube. Ready? It's either covered by the capacitance of the blocking tube or the blocking capacitor. Here, more capacitance widens this out. Less capacitance shrinks it up. So let's say we had 1,000 picofarad here. That's about what we've got in play. We're going to have a very resonant tight dip, which is what we want. The top side, remember how big the dip was? It was super wide. That means there's just a little bit too much capacitance. If we were to back that down to, say, 500 picofarad, the dip would get so narrow that if you had trembly hands, and let's face it, most of us in the radio hobby have a little bit of trembling hands because we're a little bit older, and we get up here and okay. For me to get that to smoothly work, I'm having to literally, by the hair of my chinny chin pubes, move the knob super smooth. Well, if you're an amp builder, you know that if you make the Q of the amp too narrow, it makes it almost impossible for somebody to tune it. And if you add too much capacitance, it makes the Q so wide that you have to make huge adjustments on the knob. There's a delicate balance. So now we know that the natural input resonance of this amplifier for the frequency that we're wanting to talk on, which is somewhere between 20 and channel 26915, is a 6. Well, how do we get that to be lower? They're missing a capacitor. If we took like a 100 puff doorknob and just attached it to this plate and came to the 5th turn on this coil, watch what happens. So 1, 2, 3, 4, 5. Yeah, we don't have a good bite on the wire. Pardon me. Excuse me. Oh, pardon me. Okay. Trying to show this to you without soldering the actual capacitor to the coil, which is why it's jumping around so much. But by adding another capacitor to it, we can reach a butter zone we're right there at it. There's a sweet spot. Bam. So we can get him relatively close. Let's go back the other direction with it. .017. You understand?
Yeah.
So now for every watt that we put in, only 0.017
Coming back.
is coming back versus, okay, so let's stretch that out so we make the math match what we were talking about earlier. For every 10 watts that we're putting in, we're getting less than 0.017 of a watt back. Now we're in resonance. It's really hard for people to understand or visualize until they have it laid out to them like this.
Right.
So this box was awesome for old school. I'm not a fan of pi input circuits. I'm a really big fan of pi L. Although in the amplifier world and the solid state world, we do a lot of pi.
Yeah.
A lot of pi. If you think about it, most of our solid state boxes are pi tuning networks on the output for matching. So even on 26915 is still a 1.9. But if all we got to do is reach over here and turn this, not even a quarter of a turn. I mean, it's not even the width of the tape that I'm using for a marker. Now we can drop this right, bam, in resonance, 1.019. But once again, I cannot stress this enough. This data is just to simply get us in the ballpark. Because remember, it puts out a quarter of a watt, and we're going to need to put roughly 900 to 1,000 watts worth of drive in this box to get it to its full output power, right? Mm-hmm. So we have that to think about. Now, we have to go over here and we have to think about the power supply. The main reason he came here is he wants to put the power supply in a metal cabinet. There are some serious safety concerns that go along with having a metal or a wood power supply enclosure. And I mean deadly concerns. If we open the lid on this thing, let's go ahead and we'll just flip the lid open here on the top. This is your output circuit. This solid wire. And that goes over here to this bleeder resistor. And then the bleeder resistor is mounted to some standoffs. And the screws for the standoff go halfway through the plywood. So now if the plate voltage on this amplifier is right, which we don't know because there's no data tag, there's no information, there's no nothing on the inside of this power supply, no voltmeter, no nothing. The voltmeter is another huge safety concern. But let's say you took your hand and just ran it by that piece of wood and your other hand is on the metal case of the amplifier. That screw can conduct through the wood at 7,000 volts. We're talking this much wood for insulation, jump into your hand, run across your heart, go to your other hand that's touching a ground or the power supply or the amplifier deck and kill you. There's lots and lots and lots of that going on here. We have a high voltage board that's being held up by a zip tie. I'm not saying this is the way Bojangles put it together, because we know that there was another builder. We're not going to put any names out there because we don't want to run anybody down or make anybody feel bad. But we know another builder has had his hands inside of this, and he, quote, redid the high voltage supply. The other thing I take serious issue with is down in here, this is our filtering board. These aren't even computer grade capacitors. They're something else. Technically they're, well, 450 volt, 100 UF. I question, once again, the whole board is held down with screws that go into the wood. We don't know how deep in the wood it goes. It doesn't matter. Wood's not a great insulator for this.
Yeah.
If you look around in here, you'll see that this thing has been blown up a couple different times. Very basic. This power supply is very basic. It doesn't have a soft start. That's another thing that's kind of tripping me out. It's just got an on contactor. So you bring on one pole, then you bring on the other pole for the 220. I mean, it's a single pole, 220 single with it. Okay. So you're bringing on one half of the phase and the other half of the phase because it's split. You are your own soft start circuit, which is very dangerous. I don't know. I question things. It's just me. I'm questioning things. There is no common unified ground between the power supply and the RF deck. This is supposedly your high voltage ground, and then your cabinet ground or your power supply ground or whatever you want to call it. What am I hooked up on there, Don? Goes through this plug right here. Now if this was a metal box, we could run a ground wire from the metal box up to the RF deck, and we wouldn't have to worry about this connection coming loose, or possibly this connection, which is a single piece of 22 gauge wire, by the way, coming loose, which technically is large enough to carry the current. I don't know. I'd rather have it inside of a metal box.
Yeah.
Which we bought a cabinet just for this, just in case. So we'll see.
That's why I was always afraid of it.
Yeah. This is a Henry filament transformer that's in here. And then I believe that this is also a Henry plate transformer. And if that's the case, I don't know if we're ever going to be able to get the voltage high enough to get this tube to really take off. But either way, we're going to do the best with what we've got here to work with. We're going to modify this input network a little bit. The output network's fine. I would like to change the tank coil out to something that's significant enough to carry the power, because we can see the tank coil is completely discolored and basically is trying to unsolder itself.
Yeah, I think that needs to be issued.
But,
Addressed.
my friend, we have been out here for 8 hours straight now. We
Really?
fixed, yeah, we've literally fixed everything else that you've brought here. Your eyes are starting to look like slits. You're like,
Mine are.
Yeah, you're tired. You started what, at 4:30 this morning?
I got up at 4 o'clock.
Yeah.
Up to 5.
So we might have to come back around to this tomorrow. You feel okay with that?
Oh yeah, no problem.
Because it's 11 o'clock now. Gentlemen, we'll see you in the morning. I'll see you. Click, click. Been a fun afternoon so far, hasn't it? We've been out here since 7:30 this morning. It's now 11:30. So we spent most of the morning testing and certifying the power supply, and then we completely redid the input network, which is this knob here. We added a 100 puff doorknob and got rid of this shit completely. This was their idea of tapping it for resonance. Got rid of that pile of stuff, put a brand new coil in it. We got the input really dialed in, then we did the pass-through tune on it, and then we started chasing the watts. So we started out low, and with 50 watts in, the tube was blowing 400 degree air out because this was so far out of tune, right? So I switched over to the analog meter and started playing with it over here on this one, and then we started believe it or not, RF was getting into the analog meter. You would not believe the amount of stuff that this thing has interfered with. Like, My computer monitor's off. My speakers of the computer are off. The amp volt gauge, which is effed off, it really is effed off now. That's because we had the lid open and everything was out of tune. So once we started to get it to line down, I went ahead and came back to the digital meter. I'm not quite used to using this yet. This has been a little bit of a show, hasn't it, Don?
Yeah.
That input tune was so bad. When we started out, I had a 100-watt element in here, and I was putting 150 watts into it, and it was pegging it in the corner. It was just out to lunch, completely out to lunch. So now what we've got going on is, let's go over here and let's zoom in. And these are legit numbers that we're going to show you. So as we can clearly see, we've got a 10,000 watt element here, 10,000 watts here, it's in peak. We got a 5,000 watt element here, and a 5,000 watt element showing here. Got a 5 watt slug reading and reflect, back from the 10,000 watt dummy load. So what we're doing is putting a little bit of drive into it. Hello, 1 2 1 2 1 2 1 2 1 2. So we're seeing about 900 peak here. Hello. We're putting about 400 average into it here. What that translates to, and our voltage is still a little low. Our resting voltage is 5,300 volts. So under load, we know that we're dropping to like 4,700 volts. We got one more tap we can go on the transformer. We figured that out this morning because there's no labels on nothing. So we had to turn everything on and then very carefully with the high volt probe, measure everything and figure out what we've got. So we got one more tap. We can go to 5,300 pre-rectification. The next tap down, the one that we're currently on, is 40, I made labels, hold on, 4,600. 4,600 and then rectified 53. So yeah, we can go up a little bit. We'll go up another 1,000 volts eventually before this is done. The downside is the filter caps that are in this power supply. There's only 6 UF worth of filtering. Technically there's enough voltage there, but there's not enough electrolytic filtering, which is leading to the hum. The other reason why this amp came here: 1, it wasn't putting down any power; 2, the input was horrible; 3, the pass-through was deplorable. I mean, deplorable. There was no capacitance on the pass-through on this amplifier at all. So with, let's say, 1,000 watts going through it, like 980 watts, like what we're doing now, going through it, we were seeing in reflect what we were seeing, 300 and something watts, just the RF passing through the amplifier, not doing anything. So I went in and added a 25 puff 5 kV doorknob, or 7 kV doorknob, pardon me, and then added another 7 picofarad worth of metal clad capacitance on top of that. And that got our pass-through tune down to 1111111, less than a watt going through. We're on a 5 watt slug over here, which is great. That's way good. So now on the output, with the plates volts down, but we're demonstrating that everything's working, that the tank coil's resonant-ish. I mean, the tank coil's still getting pretty hot, but 95, 9800 peak, no problem. 4,200 on the average. And 356 milliwatts coming back from the dummy load. Now our input tune, which we have spent hours working on to get absolutely down as low as we can to try and save his drivers from getting blown up again. 111. That's a 1 watt element, or a 5 watt element, by the way. That is less than 1/4 of a watt, half a watt. If we wanted to be showy about it, we'd put a 50 watt element in this hole and be like, 1 1 1 1 1 1. Oh look, there's nothing. Hello. Well, here there's nothing. Literally nothing. Hello. 1 2. Hello. Meanwhile, our output numbers haven't changed at all. Hello. 1 1 1 1 1. So pull that 50 out, put the 5 back in the hole. Hello.
my watt slug. Hello, 1, 2.
Here's the problem that we have because the filter bank, which I'm having a really hard time believing that Bojangles put the filter bank together. It doesn't look anything like Bojangles would build. Just listen to the sound of this. 1, 2, 1, 2, 1, 2. That's me talking, just picking it up off the air with a listening radio.
Hello, 1, 2.
We can hear that 60 cycle hum pretty good. There's just not enough filtering on the high volt board. So we're getting a little bit of AC ripple. But we have the solution for that here. Feel like you've learned anything today?
Oh, yeah.
This is our high volt meter. This doesn't correspond to anything. The numbers on the front don't mean anything. It just means there's high voltage and then 0. It drives me nuts. So apparently this is our filament voltage. This says 100, 150. So we have 125 what? AC volts, DC volts? We don't know. We don't know. But it's shiny. It's pretty. It's real shiny. We like shiny, don't we?
Yeah.
Shiny shit's awesome. Yeah.
Hello, 1, 2, 1, 2. 1, 2, 1, 2. 1, 2. Hello, 1, 2, 1, 2.
That's the way it should be working. Now if we get our plate volts up, put another 1,000 on this, those numbers will dramatically change, Don. They'll come way up. We'll be 13, 14, probably 13,000. And we'll be about 5,000 average, 4,000, 4,800 average, somewhere in there.
Hello.
Yeah, it'll be over 5,000 watts average.
Oh, yeah.
And the tube will run even cooler. By the way, we had
That's a
to
good
overhaul the bias this morning too. We changed that around. So we've been sitting here keying it pretty consistently and just having fun with it. And survey says 176 exhaust air temperature. Versus, man, when we first fired this thing down, 400 degrees, because I kept explaining to Don, I'm like, it's nothing wrong with the amp other than it's out of tune. The tube is making power, it just can't come out of the RF deck, so it's sitting there ping-ponging back in the tube and it's getting everything hot. So we're making progress. So we're gonna break for lunch. Let's go to the metal shop and let's see if we can get some Albright stainless for that new cabinet. And power on, not really. It means filament. That's our blower, which is separate. And then we got our 2 other breakers over here on the high voltage box, but can you believe we passed 9,000 peak through that piece of RG400 for an hour this morning and it didn't even get hot?
Yeah.
Isn't that coax amazing? One step at a time. One step at a time. All right, let's go get some lunch. Gentlemen, we shall return. Good morning. So we're out here and I'm converting this cabinet over. We spent all day yesterday painting this thing. So this is bare, raw, just brush prepped aluminum. And after we got it all put together, I took a white cotton rag. And no, this isn't dirt on my hands. This is paint that is stained in my hands. I took a white cotton rag, which was a mistake. Oh God, did I pay for this mistake? And I took denatured alcohol and I rubbed the whole cabinet down. And I was, you know, attempting to get oil off of it. And then I went and wiped it down again with a towel, just a microfiber cloth. And then we went to painting it with ceramic paint. And little did I know that the white cotton cloth had left little microfibers all over. So we're out, you know, painting it. And we put down our first layer and it was kind of pity. And he wants a high gloss black to match the Bojangles cabinet, right? And We got 2 layers down and we're looking at it and I said, Don, that's not right. So then we let that dry, and then I got out my non-directional orbital sander and proceeded to start sanding. And that turned into a thing. So I ended up having to chemically strip the whole cabinet with acetone. And then I used my prep tool and I re-prepped all the surfaces of the cabinet last night, including the cabinet. And then we shot 3 layers of paint on it last night. This is going to look just like a Bojangles amp when we're done. I've got stainless steel cut for the front. We're going to use the same control interface on the front, but we're going to make some changes. Because the cabinet's not made of wood, and that was a huge safety concern. So let's pan over here and let's look at the cabinet. Here's some of the hardware. Like, here's one of the safety concerns that we had, to give you an example real quick. So, where are you going, camera? Let me lock it down a little bit. This screw here, this is our high volt filter board, and this is also the main reason we're rebuilding this. This screw went through this board right here, and it came out right by this positive rail, right? So ground's here, and our positive output is here. The screw is making contact with the high voltage lead. Well, the screw is the same thickness almost as the body of the wood. Okay, so maybe there was 1/100th of an inch worth of the tip of this screw that wasn't sticking through the wood, and that in this cap bank is too small. We'll come back to that. So if somebody would have brushed this cabinet and then also touched the RF deck, they would have died. Just the 5200 volts or 5300 volts that were present would have jumped off the tip of this screw through the wood and just killed them. So that was a thing. The other problem that he was telling me is that we got the amp all running, and I said, okay, let's, he's telling me about what he had going on, and he goes, everybody was telling me I had a really bad hum. And I said, well, that's always your electrolytics, your filtering supply. So as we can see, these are 450 volt, 100 UFM, okay, electrolytics. This one's split. It's swollen. It's been so hot it's split. So even if we do the math, so if we take 14 or 100 and divide it by 14, because there's 14 caps here, it works out to be about really a usable 6.5 UF, which is way too low. We need closer to like 16 UF to get the AC ripple. Even with modern 10A10 diodes, there's still quite a bit of AC ripple that we have to try and snub out. And that's what we do with the electrolytics, is it cleans the DC up. So let's take our little analyzer here and see what our analyzer tells us. Basically what I'm telling you is this is less than half of what it needs to be to properly filter this thing. Now I happen to have my personal 6K amplifier, my 3cx3000. Hey, good morning. Mr. Log Trucker's just getting ready to join us here this morning. I'm going to pull my Henry oil-filled cap out of my Henry 6K, and we're going to mount it up in here, which is 16 UF at 7,500 volts, which is going to allow us to go higher in voltage. But if I turn the analyzer on, the analyzer shows us that we've got 7.3 UF worth of filtering. So it's not even half of what it should be. But the fact this cap is failing is the reason why he's got so much AC hum. So when he told me that, I just quickly took my monitor radio and dialed over to the frequency that we were operating on, and you could hear it as, it was bad, wasn't it? Yeah, a little rough.
Not what I want to hear.
Right, so we've got to come up with a workaround for that. Because we're not using a wood cabinet, we went ahead and I created, for his bleeders, this is his bleeder circuit. We went ahead and I created a standoff. These are nylon. This is standing off like 1.5 inches from the cabinet. And then we have another 1.5 inches from the next high voltage point. So we have literally 3 inches of separation between the cabinet physically as an electrical path from ground to the bleeders. And then this is some really thick G8, G7 high temp fiberglass. The other thing is where the high voltage went through the cabinet, it literally just went through a hole in the wood, which was right here. Right there. So how I'm gonna go about doing it is, once again, I took some high temp G8 or G7 or whatever it is, fiberglass, and then we're gonna use a strain relief and run the high voltage through this, and then there's a solid inch worth of clearance on each side of the plastic connector, and then we've got high voltage wire that's gonna go through that as well. Way safer than just running it straight through the back of the cabinet. So those are just a couple things. We're gonna add a vent. This does not have any kind of air circulation in it whatsoever. So transformer makes heat, the bleeders make heat, the rectifiers make heat. Just from us sticking around with it for 20-30 minutes yesterday, when we opened the lid up, there was like this wall of heat that came out of the wood box, like come rolling out of there. So I'm going to take a little, probably 220 volt fan. We'll put it down here to blow some cool air in. And then we've provided it also a 4-inch exhaust, and we're going to use some stainless steel screen so we can keep with that black on silver theme of Bojangles. Yeah, that's where we're at this morning. Like I said, log trucker just woke up, so I'm going to say good morning to my friend, and I'm going to continue working. I'll have another update for you here in a little bit as we get a little bit farther along, but eventually everything that's in here will make it over here. This will be on wheels, and I think it's going to look pretty sick. We're just a few hours away from being done with this, and then I can send him on his way. And then there's this little hole that's up here in the lid, or in the side. You know what that's for? This magical thing called cabinet bonded ground. Anytime you have a connection on a high voltage supply, you always want to create the shortest path to ground from the power supply to the RF deck on a 2-piece unit as possible. I understand that there is a ground that is provided through the 110 volt plug here to go up to the RF deck to power the filament and the blower and all that kind of stuff. Who's to say that the plug is perfect? Not me. Who's to say that, you know, like my buddy Showdown, they had a ground on the box, on the power supply, and then they had a ground on the RF deck, and then the ground wires went all the way outside to a ground rod. And then there was a clamp that was on a ground rod, and that's where the grounds went together. So, you know, 10 feet of wire out, 10 feet of wire back, really shitty connection at the ground rod, and that ended up getting so corroded that there was no electrical connection there anymore. And so it was using the coax and the house electrical ground and stuff to complete the high voltage circuit. Kind of like this shit. So he was over trying to get his buddy's RF, what they thought was RF, out of the station, and he put one hand on the power supply and the other hand on the RF deck, and all the high voltage went through his palm, out the other part of his hand across his heart, and almost killed him. Because 2-piece units are deadly as shit, and they will kill you deader in hell. It'll hurt the entire time while you die. I've done many safety videos on this about how this is very dangerous, and the number one thing that you can do to prevent yourself from being murdered, death, killed is to have a very substantial wire that goes from the case of one unit to the case of the other unit as short as possible, that's committed with a crimped and soldered connection. And not relying on a, like, straight up from Ace Hardware or Home Depot 110 volt outlet. I mean, that's just my opinion on things. Of course, people die, and we learn these lessons from death until we get into the CB amplifier community, and then everybody's life's their own risk, I guess. So, all right. Let me get off my soapbox. We'll be back. All right, well, we're moving right along here. I think where we left off, we had the bleeder circuit in, and we had the back plate with the Hiko strain relief on it. So now we've got our high voltage wire run with the proper strain relief on it. And this is the old high voltage board, which is, if we count the diodes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Which means we can run up to 7,000 volts through the rectifier. Yes, these are 1,000 amp, yes, they're 10 amp, but we always double that so that each diode is only seeing half the voltage at 500 volts. So if we count up on one leg of the string, 14 down 14, so it means 7,000 volts. Our cap, our oil-filled Henry capacitor, is good to 7,500 volts, so it gives us another 500 volts worth of headroom. This second tap is 5,600 volts, which is going to be roughly 6,400 volts rectified, versus the 5,300 volts we were running before. We're going to put a full 1,000 volts more on it. The problem is when the amplifier is running, it's underneath full load, that draws that 5,300 volts, it actually pulls it down to like 4,700, 4,800 volts. So now it's 6,000 or 5,600 volts because we have the right size oil-filled capacitor in here. When it's underneath full load, it's going to drop down to about 5,700. So only about 200 volts above the actual 2-spec rated voltage. Now, you want to see the soft start that was in this before, you guys? We're going to reuse these Curling breakers, or Cuttingsworth breakers. This was the entire soft start circuit. You would turn this on, then you'd flip a switch up on the RF deck, and that would drive this 75 amp contactor. Contactor would close and dump 100% of its shmoo directly into the transformer. The only way we could get away with that, though, was because the capacitor bank was too small. And the diodes could easily overcome the dead short of that capacitor bank and just push right by it. Well, now that we've got the proper sized oil-filled capacitor in here, it's just the way they are, you guys, we had to build into a soft start circuit. So we're going to reutilize the breakers, but we're going to do them differently. We're going to have them feed the input side. So this first contactor, when it fires on the opposite side of the 220, so now we've switched to red and black wire code. So we're up to this decade. Instead of using white and black, we're going to use red and black in here. This contactor closes. The red leg goes over to this Allen Bradley. That's a 6100, and it's 110 volt, and it's a 100 amp contactor. There's 3 legs, so we're only going to use one leg of that. That 110 volts, because we're going to split it. And now we've got our ground lug here. We're going to give our ground reference to the timer and our ground reference to the second contactor. And we're going to use a ground reference over here for our fan. This is a 220 volt fan pushing air in, because all we're trying to do is circulate some air through this space, right? When this contactor closes, it's going to start this timer. This is just a couple 100 ohm resistor. You don't need a whole lot more than that. It's just to help the electrons slowly build the field inside the transformer and slowly leak voltage into the capacitor. Okay, soft start. And it only needs to be an activation for like maybe 2-3 seconds, and then we can bring the second contactor online. So the red leg comes into this port, and then you put that resistor between the in and the out of the transformer. The output leg comes over here, and it goes to the other side of the primary lead. Okay. This timer closes. Contactor is basically a big switch. It closes, and it gives 100% shmoo to the transformer. The most that we're going to have to deal with here is 50 amps. So we're using a contactor here that's rated for like way more. It's the only 110 volt contactor I have. So this $290 contactor getting fed by a $50 contactor. It is what it is. This is a 220 volt coil. This is 110 volt, which is fine. We're only going to use what's coming in on this one leg. So that in turn now goes over to our diode board. Our diode board's hanging on nylon spacers, and we got all kinds of room. This is wire that's rated to over 7,000 volts, so we can let it hit the cabinet. And instead of using 600 volt solid core Romex, like what was in the wood box. We're using all Teflon wire and high voltage on the output side going to the bleeder bank, and then we just got that brought back to ground. If we wanted to, this is where we would take and go to a fuse holder here, and then we would break in on the ground leg for the contactor down here, this contactor here, and we'd tie these two together. So if the fuse, if anything happened in the RF deck and the fuse popped down here because there's too much current draw, like a short in the RF deck, it would pop the breaker, pull the contactors off, and drop the high voltage off. But we don't need that because of what's going on in the RF deck, just saying. We got the bottom mounted up. I did reuse a piece of the wood to mount the transformer to it. And that's to help spread the weight of like the 60-80 pound plate transformer out on the pan. We flipped the pan upside down so I could get more vertical room. It seems like no matter how big of a cabinet I buy, I always end up running out of real estate. So now we've got to put the face together. The next step that we're going to do is we're going to bring all the 220 in, get that wired up, get the curling breakers on the, or the cutting breakers wired up on the front, the indicator lights, and the chrome face. So that is where we stand with this. Gentlemen, we'll be back in just a minute. Look, I got nothing but admiration and respect for Bojangles, right? And I'm not saying that this is everything that we've repaired, changed, modified on this thing is a sterling giant example of Bojangles quality craftsmanship or construction. But man, I personally feel that this is a little bit better off than, I don't know, 6 zip ties and everything bundled together going through a hole stuck in some wood. This stuff is not coming out, right? And like, even the customer who doesn't know really a whole lot about a whole lot says, man, I feel so much better about that. Hey, it's just me and you here. The customer's out having smoke. I'm so grateful he brought this over because I think he probably would have gotten electrocuted the way this thing was set up. But I'm not saying Bojangles did this because I know for a fact there has been somebody else that has had their meat paws on the inside of this and quote, redid it. So this is, this makes me feel better. Metal cabinet makes me feel better. This makes me feel better, but what would make me feel even better is if this was one unit, but yes, okay. I got to mosey on. I got to get back to it. I got to put labels on this. So this is going to be 220 volt main, 220 volt head unit, and this goes to the head unit for on off. And of course high volt. So let me get the label maker out. So we went from this scrubbed up garbage to this. What do you think, mister?
She's a beauty. It's gonna talk as good as it looks.
How's your back?
Huh?
How's your back?
Well, I can tell it's there.
It's a hurting unit. We'll miss you, Lynn. Love you. It's been a long day, hasn't it?
Yeah.
Can you believe we redid this in just a day and a half?
Yeah.
Well, I mean,
Well, I don't.
14-hour, 15-hour days, but I mean, she's all cleaned up. We got her all put back together. I got to tell you, I put on earplugs and earmuffs and made log trucker stand behind me, and we put the tinfoil cap on, didn't we? We turned it on and everything went click click the way it was supposed to. So okay, so do you remember what we were seeing out of it yesterday, Dawn? Max, wasn't it like 9,200 and something?
92.
Yeah, okay, so This is the main thing that was the most important to me, is that he get himself an upgrade in this department. That he have a soft start. Them oil-filled cans are silly expensive, you guys. Like silly expensive. I think Henry Radio's running a special on them right now. Still, it's like 179 or 180 something bucks. They've come, actually has come down, because I remember them being even worse than that, like 230 or something. The big oil-filled can. I know that when Bob and I were buying all of those for his 20s, he's got 4 of those oil-filled cans in his pair of 20s.
4 of them in there?
Yeah, well, we couldn't, because he wanted to run like silly voltage. He wanted it, well, we had to get 12,500 volts on those tubes. So 2 in series and 2 in parallel. Anyhow, back on topic. We got her all tuned out. Okay, this is what we're going to put in it for drive, you guys. 111111111. About 350 bird peak, and 350 bird about 11111, about 1100 peak. Sorry if RF gets in the microphone. Audio. Seeing consistently over 13,000. Now that's with the bird turned all the way up on the derail striker 955, right?
Hello, 1111111111111. Hello.
So we're seeing 6,000 average and just a shy over 13,000 peak. That's with 300 bird drive, which is nothing. This box can take more than that now. But let me run up here and let me turn down the bird watts. And that actually requires less current out of the wall when you turn the bird watts down. Your peak numbers will come up a little bit. Your driver amplifier is going to stay cooler. Your tubes stay cooler because it's not having to work as freaking hard for no gain. So now we're going to notice our bird watts are going to go down. Our average watts here are going to go down, and our peak watts are going to go up just a little bit. So by pulling 1,000 bird out of it, we picked up, what, another 600-700 watts out on the peak side. But over yesterday, we're seeing, what, 4,000 more? Right, what'd you say it was? 90?
92.
Audio.
So 3, 4, almost 4,000 more. Yeah.
Yeah.
That's all from going to the higher tap, going up 1,000 volts on the tube, right? And then modifying the crap out of the power supply on the inside.
Yeah. Big time.
Changed everything on the inside so it can get more current. Everything's running smoother. Yeah.
Got some air going through it.
Yeah. We're standing here going, I think we can feel air. Is the fan coming on? Because we got these aluminum covered guards on the side of the amp that match the whole motif of the amplifier. And I'm like, oh, wait a minute. It doesn't turn on until we turn the soft start on.
Audio. 1 2 1 2 1 2.
And that's really just about the way it should run. So if we wanted to, I guess we could max drive it with this 4-pill. I don't know how much more we're going to get out of it, but we can take the 490 and rail the 490 into this. And I guess our next step would be to hook up the bench 2-pill and rail into it. I know you don't really care, but I mean, I don't. Oh, wrong coax connector. Wrong. Okay, let's see. Blue. I have the blue connector here. Sorry, you guys. I slept like 3 hours last night and came out and started working on this again. I just wanted to get this done for him today. 14.
Audio.
What was our input reflect?
Radio.
Not much difference.
No reflex.
Hello, audio. So 200 more peak equals another 500 out going in. So is it worth it?
No.
Radio.
Well, buddy, you're in the big boy club now.
Right.
You're in the 10,000 watt plus club. Welcome aboard. Welcome aboard.
Yay.
Okay, well, do you want to try and max drive with the 2-pill, or do you want me to grab another driver and throw up in here? Or are you happy?
I'm happy the way it is.
Okay.
I'm never going to max drive it. Unless you want to test it that way.
What point?
Yeah.
I mean, we just threw a 6,000 watt dead key with it.
Yeah.
No problem. Anything else you want to do?
No.
Did it turn out the way you wanted, or better?
Oh, better. Better.
I wish you guys could have seen his face when we were starting to pull the cover off. He was like, "We could just reuse the old faceplate." And I'm like, "No." Remember, I was like, "Nuh-uh.
Yeah.
We're gonna go get some new stainless, and we'll completely." Hey, man, here's 63 calling. Hold on a second. Okay, so what we've done now is we've changed to the derail comp Cobra 29, and we're not really putting any more drive into it. Let me double check we're not putting any more real drive into it, but the derail comp Cobra 29 makes it do a whole lot more bird, right? So we'll see here. We're gonna put hello 1111 hello 620 bird from a 4-pill, which is stupid, by the way. Hello 8,400 bird. Remember, this thing's designed to be hit harder than this. So I'm gonna call this a win, dude. I'm stoked.
Yeah.
I think you're gonna be smashing some ducks over at your place.
Yeah, I think so.
I might have to get out of your way and let you get some talk time every once in a while. That'd require me turning on my radio, right?
Yeah, I could get in there and slam with RC and them idiots up north of me there now.
Oh, Alan. Well, Don,
Thank you, buddy.
thank you, my friend. I appreciate you. I love you. Once again, condolences with your wife. And thank you for coming and spending the last 3 days with me. It's been a lot of fun.
Thank you for having me over, taking time to...
Well, gentlemen, super shout out to my Patreon supporters down here. Thanks, gentlemen, for being here and supporting us and supporting the channel. And super shout out to Penna, because might be a Penna tube in this. I am with 63. I think that we need to change the tube out on this and to see what happens. I wish you would have brought your other tube with you, the new one. We could have slammed it in here and been like, and seen what it did. But shout out to Steam and Coax for the new digital meters. Siglant, McMahon, Odyssey, XS Power. Super shout out to all of you guys. And I'm sorry, I'm exhausted. I'm really, really stoked on the inside. Just really, really, really tired. On that note, gentlemen, I'm out of here. Bojangles rebuild.
Beauty.
See you, boys. Click, click.